बॉक्स अकडे बाजूला ಆನ್ ಮಾಡೈತಿ
Requesting all the panelists to please come on stage. Inviting the moderator, Professor P. Jianshu, to please take the stage. Thank you, sir. Calling Dr. Indra Prasad Acharya to please come on stage. Professor Meng Chia Wang to please come on the stage. Inviting Professor Feng Zhang to please come on the stage. Professor John Sabni to please come on the stage. And also inviting Dr. Randall Joseph to please come on the stage. Thank you everyone. I now hand over the session to the moderator, Professor K. Jianshu.
Good afternoon, everyone. Now is the panel discussion with the focus on the advances in geotechnical engineering in Asia. We have 5 panelists. I think according to these topics, we will have like a short presentation for each panelist, and then we have some kind of interaction and question Q&A. And if we have time, we can answer some questions from the audience as well. So let's start the discussion from Anil Joseph, please.
ಪ್ರೇಮ
Yeah, good afternoon, good evening all. It's a pleasure that we are discussing here, and to accommodate all the presidents of Asia, we have come with these 2 panel discussion. One is advances in geotechnical engineering in Asia, which is happening now, and tomorrow also we will have a panel discussion by presidents of the Asian region. So I would like the other people to talk. Being the host country, we will reserve it to the last, and we would like to hear from the other people who wants to carry on with the discussion on the topic.
Okay, go ahead.
Good afternoon to all. Myself, Indra Prasad Acharya, Professor in Civil Engineering from Tribhuvan University, Institute of Engineering, Nepal. Currently, I am serving as a President of Nepal Geotechnical Society.
Yeah, discussion for the panel. Could you please talk about a little bit more about the challenges in Nepal and what is, the development options in Nepal, especially in geotechnical engineering in the next 1 or 2 decades? Give us some idea.
Yeah, geotechnical engineering is a very emerging discipline, an emerging field in Nepal nowadays. After 2015 Gorkha earthquake, everyone feels that it is necessary in government sector, in public, in private, everywhere. They feel that geotechnical engineering is must for any infrastructure development. According to that, all the government agencies and all the private companies, and they are now following their course of geotechnical engineering. In Nepal, since 2002, Tribhuvan University started that master program in geotechnical engineering. In every year, there are 20 students in that discipline, and we are also conducting PhD program also in geotechnical discipline. That's why it is very emerging field, emerging discipline, geotechnical engineering in Nepal. But there are some challenges, and because some challenges in, to develop and to combine with modern geotechnical engineering, we are seeking support in academic institute and other consulting firm and other private partners also.
Professor Ong from Chinese Tech Society, I know that you have an appointment.
Yes.
You want to say?
Yes.
Okay.
Okay. Good afternoon, everyone. I'm Minjia from the Chinese Taipei Geotechnical Society in Taiwan. So, further in our society focus on this topic, I think we focus on two aspects. One is the sustainability of the civil engineering or geotechnical engineering, and the other one is in Taiwan we encounter lots of disasters such as typhoons, earthquake, landslides. So how to mitigate the disaster is another important aspect in our geotechnical society. So today I prepare a topic about my research related to the carbon dioxide mitigation. I think I need about 10 minutes to present my research. Too much? Okay. So I will try to show them my research, my lecture. Okay, so we open the okay, next one. So in this conference, I prepare research, so it's my pleasure to share the topic with you. The title is a hydromechanical coupling analysis of carbon dioxide migration in stellar aquifers. So as we know, that global change becomes a very important topic. So in this topic, we will focus on how to conduct the carbon dioxide storage in Taiwan. Next. So I think I see this slide. Please go to the next one. Next one. Okay. Okay. Okay, so in Taiwan, we can see the major sources of carbon dioxide emissions are concentrated around the western coastal area in this area. So at the meantime, the wood hills and the plains of western Taiwan provided the most suitable geological information for the carbon dioxide storage. So we can find very suitable sites in this area. So these emission sources overlap with the potential storage sites. So it provides the region's stretch importance for CO2 mitigation. So in this study, we aim to clarify how CO2 injection affects the cable rock stability during injection. Usually when we talk about the CO2 storage, we need a cable rock and a reservoir. So in our study, here are the objectives. We try to develop a hydrochemical coupling model to simulate CO2 migration and the corresponding stress responses of the cable rock during injection into saline aquifers. And we validate this model through the benchmark simulations. And then we apply this model to a scale case in central Taiwan to evaluate the Cape Rock integrity and identify sample injection conditions for CO2 geological storage. So for the methodology, we adopt the console multi-fix to model the complex hydromechanical coupling resulting from the CO2 injection. So here we have two kinds of model. One is the two-phase flow analysis. So we have to consider the interaction between the water and the CO2. So we have to consider the saturation of the CO2 and the water, and we have to consider the capillary pressure in the rock, and we also have to consider the relative permeability of the two-phase flows. And okay, I see. Okay. So we also consider the hydrochemical coupling analysis to consider the strength of the rock. So after we establish this kind of model, so we implement this model into the software, and then we try to simulate a benchmark problem. So here you can see we have two reservoirs, and one is between these two reservoirs we have an impermeable layer. This is the Cape Rock. So we try to compare. We try to analyze this problem and compare the results in the research. Okay. So in the left side, this is the result from the research, and this is from our result, and our result agree well with the literature. And for the major distribution, we also give a very good result with the literature. And we also simulated the leakage ratio in this area, and based on our simulation, our results agree well with those from other academic institutions. So we apply this model to a real site, and based on our simulation, then we find, based on this calculation, the CO2 injection will not affect the stability of the Cape Rock. So this is my study.
I have a question for you. Do you know, is there any plan for the government related to your research? Give us some idea about the carbon zero policy from Taiwanese government. Is there any policy proposed already or enforced already? You know that? Because your topics relate to carbon zero, right? Yeah.
So in Taiwan, our government provide a little carbon policy in 2015. So I think before 2050, we have to find some suitable site for the CO2 storage. So based on this policy, we have to develop this kind of technique to fit the goals of zero carbon dioxide policy.
Maybe I can say a few words. In Taiwan, we have a long-term objective related to carbon zero and green energy. So some of you may know that we stopped the operation of some nuclear power plants. We tried to replace the nuclear power energy by green energy and also thermal energy. So we have a lot of the new projects undergoing, including an offshore wind farm and also some geothermal energy exploration. So according to this policy, we geotechnical engineering professionals will also get a lot of chance to dig in these two major fields. I think if you are interested in those two major fields, you can contact with Professor Ong. He has some connections as well. Okay, let's move on to Professor Lee.
Good afternoon. Actually, I prepared a 100-page slide, but if I present that one page, Dr. Shaw will kill me. So I said and briefly discuss the Korea's experience in the pharmaceutical engineering, because all societies have the same issues. Because in Korea has the very soft area, and also we have the very hard one, and rapidly growing urban systems. And also, I think about that Dr. Anil asked me to present the panel discussions. I talk about that and investigate some structures regarding for example, airport, bridge, railway, port and highway, tunnel, urban survey, and urban oil storages, and also waste repositories. But rather than focus on the structures, I would like to highlight how we study and improve and also monitor the ground itself. So I have some 4 topics. First one, understanding ground behavior, and the other one is the ground improvement and experience, and also expanding underground and rock engineering. Another one is from instrumentation to digitalization. First one, in West area and Southern area in Korea, where the very soils, and also Hanmi is also in the Southern one. So Korea's first history of geological engineering began with the salt alluvial deposits along the Han River. In the early years, like the beginning of the 1960s or 50s, residual sediment and long-term consolidation were the most serious problems. So our junior and senior geological engineers in Korea, they have realized that without understanding time-dependent behavior of the soil, the root structure could upset. So this realization led to the establishment of the field instrumentation cultures in the 1980s and the 90s, and until now, including sediment, piezometers, and includometers, and radar automated sensors nowadays. That is very common one. And through those instruments, that we build a strong feedback within design, construction, and performance. That is the become of the natural practice now, right? For example, run directly from ground. Second one is the ground improvement and experience. As I told you already, certain part of western part is the very soft areas. And also in Korea, actually it's one of the if we say that Korea is a very, rapid system, rapid countries, dynamic countries. So rapid industrialization in the 1970s and 1980s, we faced extremely soft soil in reclaimed, lots of reclaimed area and coastal areas. So ground improvement technology was the issue. And so we applied and refined the combination of some kind of methods, the combination of conventional methods, including the sand drain, DVD, vacuum consolidation, and center compression power, dismantle mixing method, and geosynthetic also. Also at the time, at the beginning of the development of the Korea, we adopted some kind of method from the Japan or other countries, but after that we tried to adjust to soil conditions. I mean, the internal method was adjusted based on the soil conditions, such as minerality and compressibility. And also many case histories, including airport, ports, and highway, railway, and also high-speed railway, provide real replicated data that became the basis of the design chart and national standard. So we have that is another one. And so from that, those experience, Korea moved to the performance-based improvement design, and complex particularly low component area. And another one is the expanding underground language here. You know, as the country became urbanized and focus shifted from the surface ground to the underground space and routes, actually, as you can see, is the major underground space. And large-scale tunnels, underground canals, and energy storage facilities require the combined understanding of ground mechanics underground and the construction of oil storage caverns. We have the several oil storage caverns in many places. In hard granite, the granite includes water column sealing systems. That is a really complex one, and also hydraulic capability, which will influence our approaches to understand waste infrastructure. That is a big issue nowadays. And deep geological research level big issues worldwide. And through this project, we are developing a ability to control not only the surface sediment, but also interaction between groundwater, rock, and engineer bearings. And finally, last one is the instrumentation to digitalization. Today, Korea's geological field is rapidly transforming into data-driven displays, not like the analog system anymore. So standardized monitoring programs for sediment, fluctuations, vibration now feed directly to the digital platforms such as the GOP. And public agencies, including the Ministry of Land, Infrastructure, Transport, have begun to link geographical data with the asset management, even asset management, and digital twins. There is a big issue too. This enables continuous observation of ground behavior and predictive maintenance of infrastructures. Also, at the same time, artificial intelligence and remote sensing are becoming the key tools, as Professor Yoon Chung-sik mentioned yesterday. And machine learning models showing the field monitoring data can predict the urban subsidence. In urban subsidence now is a big issue of the whole cities. Right? Small sinkhole and large sinkhole around the cities. And slow stability, even seasonal grounded information. So integration of the insights alongside the sensors provide a real-time map of how our ground breeze move beneath the seas. So in short, Korea's geological engineering has evolved from empirical design or conventional to the intelligent ground management. So I believe the next stage of the ASEAN collaborations will come from the sharing data, monitoring system, and digital standards so that our region can achieve safer and smarter and more resilient structures. Thank you very much.
Okay, thank you, Professor Lee. Professor Zhang, I mean, Professor Zhang, Professor Lee talked about the challenges they have and initiatives of the development in Korea. Maybe, as we know, China had a very fast development for the past 10 or 20 years. As I know, we also have some challenges now. So could you please give us some ideas? What are the major challenges and what is the major directions for Chinese engineers?
Okay, this is a big talk, so I can't give you a satisfied answers. But I just wanted to say something about, because your topic is advanced in geotechnical engineering. This is a big topics, and I just know these topics 2 days ago, So I just wanted to, share some viewpoint with you, because usually when we're talking about research, we are all professors or engineers, geotechnical engineers. When we're talking about research, usually we divide into 2 categories. One is so-called academic or fundamental research, mainly try to identify the mechanism of something happen, or we don't know. Another type of research is so-called engineering-oriented, that you should need to solve urgent problems in practical engineers. So these 2 different types of research I find is largely dependent on the, developing stage of each country, because our Asian nations are very diverse. Each country has a different level of development, don't like the United States or the European countries. So in different stages, you will find the weight on fundamental research and weight on the, application engineering-oriented research is quite different. I still remember when I was the student in Tongji University in 1984, almost 40 years ago. The GDP of China is only $200 each year, almost 1/100th of Japan, less than. But now, after 40 years of development, the economic developed very quickly. However, if you're looking back the activity of the research in geotechnical engineering, you can find most of the research now, it is changing. Most of the research are basically focused, great part of effort is focused on the engineering applications. Even for the university professors, they develop many new technologies, which in other countries, for instance in Japan, where I worked for 30 years, you can find the university professors usually do most part of the research on fundamental research, academic matters. So this is, to my knowledge, I think, because I always compare the different countries, different economic development stages, and the different weight of their, efforts on what these two different types. So it's dependent on the stage, and if you can, weight the proper ratios of the effort on different types of research, you can make things more efficient and more quick. However, sometimes if you develop too quick, then some gaps are left and make you feel a little bit awkward or something difficult to resolve. So this is why I want to say. Now China has many big projects, faced with challenge, very challenging, because it is in the mountainous areas very difficult geological conditions. So what we should do, we don't know. We have to find out proper ways and share view with other communities to make the development.
In other words, we have to take balance.
Yes, take balance. Yes, that's right. That's right. That's right.
Thank you. Thank you. My name.
Good evening once again. So since we have heard all the people, I thought I will share my thought process in this. If you look in Carl Tersaghi, a mechanical engineer who developed all the theories of geotechnical engineering. So one message is that knowledge is more important than the particular degree which you are going to get. And your experiments also brings in a lot of knowledge to this. Carl Tersaghi pointed out that foundation engineering is more of an art than a defined science. And then it's a beautiful, like our Professor Madhav says, moment we move from steel to concrete to soil, it becomes very difficult. It's very difficult studying the property of one person and how to understand the behavior of a crowd. So that's the biggest challenge we have in geotechnical engineering. We have, over the last 100 years, advanced quite a lot of technologies has come in. But what I feel, what we learn and we need to know is that the failures has to be shared, and like Mark pointed, geoengineers should be without borders. And if we can share the data of failure and success, it will help us come together. And strongly believe Carl Tersaghi made the first 1936 International Society Soil Mechanics is based on this concept that the soil is very difficult to judge and we have to share our knowledge because it is buried below. So from there, if we emerge in what is the advances happening, lot has come up, the technology has gone from drilling to deep boring to the cross-code imaging to the big data and artificial intelligence. I feel the sharing of the knowledge, sharing of the problem, because it's all unique, like Fence had pointed out, it's all unique in each cases, or like John Subley's case. There is a typical variation on each area which we are going to look into. Sustainability has pointed out that the hydrocarbon theory. So it is very important that we have how to control the carbon dioxide emission, and also has to be looked into our geotechnical engineering practice. Suppose if you going for a concrete pipe or for a ground improvement, that we are also have to study the impact on the sustainability aspect based on the carbon dioxide values which is going in. So that also has to come in. These are the advances which we need to look in, and especially in Nepal, like in the Ajay pointed out, there is a lot of problem, especially in the Kathmandu Valley. There is so much of complication in the geotechnical areas is happening that going there and getting the knowledge shared is a big experience. So I believe the advances has to share the knowledge. We have to have a big data with the AI coming in. Now the future will be predicted. We might not be really just images will be able to come to that, and we have to advance that in order to prevent catastrophe. But still the failures are happening. Take the case, we have a Joshimat singing in Kerala, the entire in India, Joshimat is singing, that entire village is singing. So we have to come up with data, collect the data, there is a statutory governance has to come in. So advances in India is that it was not mandatory had to have a geotechnical investigation before. Now, for any building, as per the new National Building Code which brought in, any building more than 15 meter, the investigation is mandatory, and it has to be signed by a geotechnical engineer that the foundation is safe. So that's a big step forward which we are seeing in regulation, especially in the National Building Code coming in. And more importantly, previously only that the soil data was needed, but the foundation design also has to be done by a geotechnical engineer, has to come in, and accountability has to be brought in. So we are bringing professional engineering practice also to ensure that we come with safe and stable structures across, and the big data of collecting is going to happen. And I believe problems in all our area, whether it is a landslide, floods, or the settlement of soil, is almost the same. So the more we share the problems and more we understand how to solve the problems, helps us to work in unison. It doesn't matter. The same problem which is there, the floods in Chengdu, recently we saw how the flash floods happened in Chengdu. Or take the advanced country, USA, in Texas, what happened? 100 people lost their life just a flash flood. Or like California fire, there is no solution. Technology is advancing, we have to bring in technology together, breaking our barriers, come together, share data, and come up with solution so that we create a safe and sound structure for the future. So for me, advances in geotechnical engineering in Asia is not limited to Asia. We have to share our knowledge, make it all unison together, like the Kartasaki plan way back in 1936 with JD starting in 1924, and we will be again meeting in 2026 to Vienna to understand that. And if you particularly talk in, there are so much of new technologies which are coming, but since being a discussion here, we would like to hear from each and every one of you how together we can come up with solution and what are the benefits each country has so that we can share with each other and improve our knowledge in this. And especially thanks to the international technical committees, like we work on field observation, like I am part of TC220, where we have a field monitoring and instrumentation. We have a big lack of instrumentation as far as I feel to understand the soil behavior. And the TC206 on observation method, that we are collaborating with field monitoring instrumentation and design as you go, like our Mother Vilada points out, when they designed the Jana Bridge in Jammu Kashmir, the tallest with such a big, so much of geotechnical challenges. So this we have to come in, observation method has to come in, and we have to design as we go and has to share the knowledge. And I believe in the future the satellite will tell us what is the soil beneath or the images with the technologies will come in to predict and tell us exactly what load the soil is going to bear. And with the AI and the machine learning coming in, the era is soon that there will be lot of advancement and all the details can be captured, but there is a long way to go, and we have to work together to bring a safe and sound structures and stable foundations across the world.
The only mention about one very important key point is that sharing experience, sharing the data. I think that for the sharing the experience, we have, we have as a new journal, including the cases. I think that would be a good right direction we could proceed. The other one is sharing the data. I know that there's a JTC too, right? They try to standardize the format of data we can share in the future. I think that's very good because in the future we will use as Professor Yo mentioned in his presentation, we might have to use the AI based on big data. So we must have like a uniform standardized data. So I think maybe some of the societies already proceed in that direction in your country. But in the future, maybe we can share with each other, between the societies. So any question or comment from the audience or any further question from the podium or the panelists? Any question? Okay, please.
Jung Sik-kyu from Korea, and University Professor, Seongyungan University, and also President of Federation International Geographic Society. Thank you, organizer, for having arranging this panel discussion. This is very relevant during these days. Well, I think the Asian geotechnical community have made a lot of advances in geotechnical engineering. We may have different ground condition, different standard, different code, different policies, but there is one thing in common these days. We are facing climate change driven geo disasters. Whenever we talk about climate change, almost all disasters are geo disasters. So we, as a geotechnical engineer, have responsibility to respond to that. So my question to the panelists is that what should we do as a geotechnical engineer to respond to the geo-disasters? That is, I think, the question that I want to throw not only to the panelists but also to the audience. Thank you.
Thank you for your comment. And as I know, both Nepal and the Taiwan experience serious geohazard due to climate change. Maybe you can share with us some of your challenges now. What you have done, please.
Thank you. Nepal is suffering that climate change that effect without doing anything. Yeah, we have rainfall induced these days. We have too much rainfall induced hazard, earthquake induced hazard. You can see that last year a lot of floods are there. Yeah, we are suffering that rainfall induced hazard from landsliding, soil erosion problem, and other due to climate change. All the that mountains seems to black, white mountains dark black. We are suffering from the climate change issue. Yeah, but we need support from the developed organization and developed country to minimize that effect and to support us. We need support to face the challenges, and definitely if we get some research on that issue and some help for academic enhancement in that area, definitely Nepal can do much better on that issue.
Professor, only one comment?
Okay. I want to share some experience in Taiwan. I remember in the past, the extreme rainfall is not very common, but in recent year, the extreme rainfall events become more common. And as 2 years ago, in eastern Taiwan, we encountered a very strong typhoon. In eastern Taiwan, the geology is very fractal. So the rainfall event causes the landslide dam. So the landslide dam is failed in 2 weeks ago. And so it causes lots of flooding in the downstream, and many people were killed. So I think now we have to face this very severe and difficult situation. If it is related to the extreme rainfall event, and maybe also accompanied with the earthquake.
Thank you. Professor, maybe something you can share the experience in Korea.
Yeah. I don't want to say I know everything, because even though I know something, but that will change. That is not true in most of the cases. When I was a college student, I was taught, like the rain intensity in Korea will be maximum 100 millimeter per hour. And all professors, teachers, taught us like that. We cannot have that kind of more than 100 millimeter per hour in Korea. But nowadays, 100 millimeter per hour is very common. Sometimes 200 millimeter per hour. So you may say that due to the climate change, I don't know what is the climate change, because I think that there is I don't know if it's true or not, but the sun's cycle, I think, but I don't want to say the details, but anyway, the climate changes. So due to the climate change, we have the natural disasters, also man-made disasters. Due to the climate change, even the man-made disasters increase and increase. For example, due to the heavy rains, the higher increase the rain intensities, our wall, the sewage systems, they cannot work like the correct or the accurate or properly. So after that one, most of people or politicians or most of people relate to geotechnical engineers, so real design is a law, something like that. That is one of the, and sometimes I'm thinking of that was. And another one is that I want to read a little bit, how can I say, the philosophical issues. We are geotechnical engineers. I'm also technical engineers. So I always ask me myself, what is the best technology in civil engineering or geotechnical engineering that improve our lives truly? And so I think of that there was many times, but You know, in the field, you know, I meet many sides. You know, also I work in many countries. I live in Singapore, Indonesia, also Vietnam, Hong Kong, even I lived in Bangladesh, over 2 years, Kuwait, even Yemen, of course. We have all countries have the same issues. We are only teaching the code, some technology, the specifications. But unfortunately, the conscience is often connected with the money. That makes us very difficult. You know, so because this is a panel discussions. So I'd like to leave us some philosophical questions. They may not have the clear answer, but I hope to hear your thoughts and advice.
Professor Lee, I have a question for you. Since it looks like we all experience the impact of climate change, that has Korean government considered to change the design code and the more higher standard of rainfall impact. Is that ongoing or is it been done?
You know, I think the total rain, the amount of rain per year is not changed. But I guess it's similar, but intensity increase. Yeah, definitely.
Thank you. Professor Zhang, as I know, I just looked at the news. Sometimes due to the torrential rainfall, some flooding in some big cities in China. So, or some geohazard happened in some area of China. I don't know, is there any policy arranged by the government or some kind of a technical society trying to improve it, or anything being done to improve the situation?
You, Professor, so always ask a difficult question to me. You know, I worked in Japan for almost 30 years and moved back to Fuji 2 years, and I know a little about the Chinese situations. So what I want to emphasize is that as to disaster, we have two different worlds. One is the prevention, another is the mitigation. If naturally it is impossible to prevent, then what we can do is just mitigations. I still remember since the 2011 Great East Japan earthquake, my university, the former university, Nagoya Institute of Technologies, established a disaster prevention center. I was the first dean of the center, worked for 3 years. And at the moment, people say prevention sometimes is impossible. And some people say you have to change your names to mitigations. Unfortunately, Nagoya University has already established a mitigation center. I insisted the name of the center as preventions, but the hardware is somehow familiar to me. But for the software, it is another question. So in my, prevention centers, we have almost 30 staffs from different research fields, and the information engineering, planning engineering, and somehow the computer science engineering. What we find is that the hardware, just like geotechnical engineering, we can do some things, and the fundamental is. But another thing is important, the soft power. Professors say to me, Professor Zhang, you do sophisticated model, you do accurate numerical analysis, but it's useless. he said directly to me, say, most important thing for instance, the tsunami attacked us, the most effective way is to educate the people, know when silence comes, most important thing is to ask the residents to know in advance which way is the nearest and farthest way to run away from the seashores to keep body safe. So that means after disaster happens, but we can immediately recover or reduce the damage to minimum size and recover it with maximum speeds and minimum effort. So this is the mitigations and the power, hard and soft combined. So this is what very important. Another thing is that cost performance. You ask the China, I don't know, the safety of the factor is much larger than in Japan. Because if you don't know certainty, you have to keep the safety and increase safety factor. But sometimes it may be too wasted. So this is another question. So I always compare these things and find a moderate, simple ways to solve this question. But sometimes, if you want to prevent a tsunami with 28-meter tsunami, maximum design, how can you do that? And don't allow any tsunamis to attack a nuclear power plant, then you have to invest huge money to keep it safe. This is my question. It is not answered, but what we do is depend on the situation and what you can invest.
Okay, thank you. I think you want to say something? I know India also is a big country. You have different problems in different areas.
So what I would like to suggest in this advances in geotechnical is that we should come with technology where prediction, prevention and mitigation process was pointed out because it's very easy in the model, but the awareness creation is very much essential for the society. And this knowledge of prediction, prevention and mitigation can be shared among the societies so that we are prepared. And we see that to reach the masses is the biggest challenge, and the awareness aspect, that flooding happens, or like in Texas, in 45 minutes, the water went up by 26 feet. So that's how flash flood is happening, like Chok survey pointed out, more than 100 mm per hour rains are coming. Or the sudden reactions are happening due to the climate change, and it is predicted that the water level will also go up. So for that we have to start preparing and make people aware and share our knowledge among the societies to come up with what are the latest technology in prediction happening, prediction of landslides or prevention methods, what you will do, and the mitigation if it happen, and how to quickly respond to a situation, and how effectively we can transfer the awareness to the people is the step which we have to conclude in, and this we should take as a system and make sure that we work with the technical committees which are SSMT now, and make sure that it is implemented to the masses is the way forward is what I believe.
Thank you, Mark. Thank you very much. In fact, yesterday, the panel discussion where Mark commented on education, so I'm going to comment on that, my perspective. Coming from a country which is the most disaster-prone in the world, from Japan, let me take this opportunity to give some comments. Now, in the panelists, you talked about prevention and mitigation. I think apart from that, we have another word now called climate change adaptation, which is more relevant in today's world. And yesterday, Mark commented on educating the young stars, especially the students in academia. I teach a course in my command undergraduate students, second year students, called Natural Disaster and Resilience, where my first slide of that lecture is related to the load versus the time. Okay? Past, present, and the future. So what is happening to a design load? So far, we just consider the design load as of the conventional, in conventional sense. So now we have to add another design, which is called disaster load. Load coming due to the disaster, unexpected events. So those loads also need to be considered in our future design to provide resilience to our geotechnical structure or any civil structure. I think that is what is most important at this, and we have to educate our students and the young engineers about those aspects in the design, in the problems we are facing from the climate change. Thank you very much.
Yes, I just want to thank you all for being here and using all. We have also something else in common, the English language, so we can all understand that this is becoming more common, which is bringing us together. Another comment is a dream, where we see featuring, just remove the word geotechnical, put it before, so it says featuring geotechnical presidents of Asian countries. So hopefully we'll all become presidents and the problems will be less.
Okay, thank you. I think I would like to briefly summarize what we discussed here. As you remember that all society, entire society share the experience they had related to geohazard and the challenges they have. Also, the society talk about the carbon zero, create new opportunities as well. Korean society share new initiatives in development of geotechnical society. Professor Zhang talk about the philosophy, the balance between the fundamental and the practical topics, and also because I discussed with him privately, I think I agree with you. Fundamental, we must not forget the fundamental thing. Otherwise, the practical stuff, right, de-oriented, not really the right direction. Also, Professor Hazard mentioned about that. The similar way, we have to think about, or we have to consider the time effect, because it's changing. The world is changing. We have to consider the changing. So, no, from the impact of geohazard or climate change, we must consider further in the future design. And I also about experience in India, and also you talk about the sharing of the cases, the experience, and also the data. I think that through the cooperation and with the integration of the TCADCs and the publication of ISSNG will be stronger, more achievement in the future. Thank you for your attending. Thank you very much.
I request the moderator to present the mementos to the panelists. Request the moderator, Professor K. Jian Shu, to present a memento to Dr. Vidyaprasad Acharya. Request the moderator to present the memento to Professor Meng Chia Weng. Request Professor Ken Jian Shu to present the memento to Professor Fen Zhang. request the moderator to present the memento to Professor John Supplee. And to Dr. Anil Joseph. And now I would request Dr. Mark Bellows, the President of ISSFG, to present the memento to the moderator, Professor K.G. Anshu. Thank you, sirs. Before we proceed to the Asian Awards ceremony, let me invite Dr. C.R. Parthasarathy, the founder and director of Sarathy Geotech and Engineering Services, for a special announcement.
Good evening, namaskar to everybody. At the outset, I thank the organizers for giving me this opportunity to share one announcement to all of you. I have published a book on offshore geotechnical engineering, the challenges that we encountered. I've been working in oil and gas industry for the last 25 years. And as Dr. Anil, I was listening to him in the panel discussion. He shared that these challenges are immense, stratigraphies are complex, and it's not the same. And I have my own personal experience too, working in different geographies from Southeast Asia, India to Middle East region. So this book has been published as a reference guide. I just wanted to hand over this to two dynamic leaders, one at the national and the international level. So I invite Dr. Mark Bellows to the stage for me. We are very happy and delighted and honored to hand over the book to Dr. Bellows. And also, I am deeply humbled the opportunity Indian Geotechnical Society has provided me as a platform to learn, network, and also an opportunity to serve as an elected National Executive Committee member. So, Sangeeta, can you please help me? May I request Dr. Anil Joseph to come on stage, please? I'd like to thank the organizers for giving me this opportunity. I request all of you to purchase this book, share this with all the large audience, and help me to disseminate this information. At this juncture, the last point I have to make, this book, I thought I will do this as an author marketing, but I reflected that this is more of a service, and any royalty that is earned out of this book, I pledge to do it for the social cause, to send it to my foundation and use that money for social cause. Thank you very much, and thank you very much.
Thank you, ladies and gentlemen. I hope you also will agree to me that when your purpose is larger than yourself, that's when you make truly a difference. Thank you, Dr. Parthasarathy. And now we go on to the Asian Awards ceremony. To chair as well as take the session forward, I invite Professor K. Jianshu, the Vice President Asia of ISSN MGE.
Ladies and gentlemen, as you may know, we have selected 4 ISSNG Asian Lifetime Service Award. Kind of confused with the Iran. ISSNG Asian Lifetime Service Award. We have 4 awardees this year. So I will invite those 4 awardees come to the podium. We will deliver the memento, take some pictures to acknowledge your achievement and your service for your whole life. So you guys should, right? I know that from Japanese society, Professor Ishihara couldn't come, right? There's some delegate represent him. I don't know who is going to represent him. As I say, you want to go? You want to come? And also the other one is Professor Asuka. Professor Asuka is here. And Professor Shin, please. Also, India, okay, please. You can see they are all well known and also senior and make a lot of contributions not only to the Asian region, but also very much in their own mother society. So please, which one? You can see this illustration, portrait of the awardees. So it's very nice stuff prepared. Thank you. Thank you for this.
So Professor Ishihara, Japanese Theatrical Society President, will collect the award. Professor Askar, Kazakhstan, Professor Isishi from Korea, and Professor Madhav,
presenting on behalf. Yeah.
Good evening, everybody. It's an occasion, sometimes, the words fail. But like I say, it's been a great experience being part of the technical family. After we went to share 63 years since I've been part of it. Having started my doctoral work in 1962, has given me a life, and I hope I have given back to the profession as much as I got. More, I would say, just not for me alone, but the people who made it could be my students, my colleagues, the people I work with all over, not only in India, but I was very fortunate to have worked with some people all over. So the challenges that came to me is very important. But in return, I would like to say, our society has been exceedingly successful in terms of fostering youth. I was a part of it too, and then there is a lady who shared it right from the day we got married. I don't know how many of you. I can share that I was doing this. I had to take consolidation settlement meetings late night, and so she had to come to the lab because give me company and walk home around 11 or 12 o'clock because we were doing some consolidation meetings way back in 1960s. In fact, she proofread my thesis, PhD, and so I've been a partner in all my endeavors. And when the work took me all over, she was there to help us, the family, and in a way she has been a bridge between me and the society. And I, as I said, don't have enough words to thank the International Society for recognizing the effort, but I'm minded alone as a civil, including your Indian society, family, and thank you.
Ladies and gentlemen, I will also say some words about Asian Service, Life Service Award. I think this for me, I don't know, it's for other people. It is like Nobel Prize of geotech engineering. It is very important for sharing these results, not only me, also my team. This is high record, maybe world record in my life. It is one of record also my team. So I am a representative of 2 schools, maybe 3 schools, anyway, from Kazakhstan, Russia, Japan and other Asian countries related with developing of geotechnical engineering and infrastructure in my hometown in Kazakhstan. So I want deep thanks especially for ICMGA board and especially for representative of ICMGA board, Vice President for Asia, Professor Benji Shaw, Professor Albert. He also made big efforts about opening this Nobel Prize for Asian representative. So I will be sharing this happiness with my family, because my family with me, my wife, my mother, 90 years old, also 2 children, and also 5 grandchildren, also my team, and also my Kazakhstan Geotechnical Society. Thank you for your attention.
Good afternoon, ladies and gentlemen. In spite of the many prominent professors and engineers, but it is great my honor to receive first ICSMG Asian Lifetime Service Award. I would like to share this happiness with a member of Korean Geotechnical Society, like Chung Sik-yu, Professor Chung Sik-yu, Jung Suk Lee, and we have Professor Jung Sam-sung, and the other. We have about more than 8,000 overall. 12,000 of about 500 members Korean Geotechnical Society. And also, I appreciate the members of the Geotechnical Laboratory at Incheon National University. They supported for my trip, and also financial support and also technical support. I should not forget to introduce my wife, who is young. You see, whenever I travel, she packed up my luggage. You know, during my vice presidency, 2017 to 2022, she packed more than 50 times, packing my luggage with souvenirs, you know. So I really indebted to her to fully support and allow me to travel many countries, not only in the Asian region, but also many countries in the world. So she is fully, really, very much thank you to my wife and my family. So thank you very much for your support and friendship. Thank you.
Happy and very pleased and very honored to receive these 2
Professor Ishihara. Thank you very much again for. And I expect Mark and Alba will come to in next December in Japan, so I will present this award directly to Professor Ishihara in Tokyo. So we will arrange this award ceremony supported by Japanese Geotech. Thank you again for your attention.
As an Indian tradition, we would like to honor all the awardees with a shawl which we generally give in India, and I will request for Mrs. Madhav and Mrs. Shin also to come to the stage.
Ladies and gentlemen, may I have your attention please? We have Professor Hemanta Hasarika from Kyushu University, Japan, who would like to make a special presentation. Inviting you all to the stage, sir. Post this, we have a cultural program in the same hall from 7 p.m. to 8 p.m. Inviting all delegates to be present here for this cultural program. Thank you.
Okay, thank you very much. First of all, I'd like to thank the organizing committee, especially Chairman Dr. Anil and our technical committee Chairman Professor Sasakamoto and also Ashish Duneza for arranging this special talk at my request only this afternoon. Today I'm going to talk about our investigation group and basic information on the earthquake and some damage to infrastructure and liquefaction is damage and some of the river embankment damage and some lessons there. I was given only 7 minutes, so I'll try to finish within that 7 minutes. So this is the investigation team of the Japanese Geological Society. Me and Professor Ohata went there to investigate the earthquake damage, along with our Myanmar team from Myanmar Geosciences Society and also Soviet consultant. Basically, it was the idea of the ATC3 Technical Committee. Professor Okamura from Osaka University is the chairman, and he initiated the process, and I was the team leader. And I would like to thank the Japanese Geological Society for providing us all the financial support for this, and also their encouragement, because the Japan Society of Civil Engineers also wanted to go there, but they could not do it, and this Geological Society could do it, all thanks to the Japanese Geological Society. And this is our investigation route and schedule. We started from Yangon and ended in Mandalay, which was worst affected, and we had a kick-off meeting at MGS on 13th, and finally a debriefing again at MGS on 17th, and covering a distance of 587 kilometers along the Asian Highway number. This is some glimpses of our kick-off meeting. And this earthquake is magnitude 7.7. Very shallow earthquake. The mechanism is right lateral type strike slip, and covering a rupture length of more than 400 kilometers, and super shear rupture is suspected in this earthquake, and this earthquake was caused by Sagaing Fault, which caused many earthquakes in Myanmar in the past. This is the strong motion record. There are not many records available. This is the only one we could get. This is in Mandalay, which is very close to the epicenter, but this record is very, very unreliable because PCA is only 0.17C. And this is the only good record. We could get some sources by Wang et al. And those data show that the predominant short period was in Naypyidaw, the capital, and predominant long period wave was in Yangon. And this may have caused the disaster in Bangkok due to the amplification of the wave in the area. So I'll come very fast. There are some damage due to liquefaction. This is in this area along the H1. You can see the damage here, settlement, and also abutment experienced huge lateral flow. These are some of the pictures immediately after the earthquake and some of the pictures that we took during our investigation. And you can see that even in adjacent farmland, you can see some poles which were tilted due to liquefaction. Also this road alignment was badly damaged due to liquefaction induced lateral flow. These are some of the pictures taken immediately after the earthquake by the Myanmar team. You can see the traces of liquefaction here. And also in Amarapura area, in Mandalay city, close to the epicenter, this city was heavily damaged by liquefaction. This city is surrounded by two major rivers. One is Wadi River, another is Mingyur River. And this, we could observe a widespread liquefaction in a shopping construction site where they have mentioned in their report that they have lowered the groundwater level to prevent liquefaction, but in fact there was liquefaction, as you can see from these slides. And close to that shopping center, there's a road, very heavy road, heavy traffic road, and you can see the lateral movement of the road towards the construction site, process of liquefaction. You can see this the curve displaced up to 2.5 meters due to lateral spreading induced by liquefaction. And these are some of the damaged subsurface voids in the road and crack development on the sides. Also, you could see some slope failures due to lateral spreading that road. Coming to bridge pier damage here in Mandalay, this is a settlement of 1.5 meters of one of the piers, and you can see the damage in the vicinity of the bridge body. And also there are some liquefaction-induced damage to buildings, especially at elementary school. This is here near Naypyidaw City, the capital city. You could see that sandball trusses around the village and near the schools. And you could see that cracks developed inside the buildings also due to differential settlement. You could see the misalignment of the rain gutter cracks on the buildings. And we performed some dynamic cone penetration test, EDCPT, at different locations, and all the test results show that end values, corrected end values, were less than 5 up to 3 meters depth, and the groundwater was very shallow at 1 or 2 meter depth. So that led to liquefaction of the ground. Okay. Coming to damage to river embankments and bridges, this is near Mandalay city, close to the epicenter. This bridge was on Asian Highway number 1. So you can see that whole highway is closed due to damage to the piers, both on the southern side here and also on the northern side. And this is due to the slope failure. As you can see, those dead trees along the embankment. And in another location along the south bank of the Mingyur River, you could see lateral flow exceeding 10 meters. And it resulted in the destruction of about 20 houses and also slope failures on the embankment roads. Also, in another location, a landslide caused about destruction of about 30 houses and causing significant loss of lives. And finally, we had a debriefing at MCS about our survey results. And the lessons learned from this earthquake is that in Myanmar, they had very few seismographs which were working properly. So we need a reliable seismograph which can accurately record the seismic motions. Also, we need some cheaper methodologies such as micro-tremor measurement to replace those when we do not have any data, and microgenation and liquefaction hazards in those areas, especially the urban areas, are very most essential, and detailed database of boreholes. These are the lessons we learned. Finally, I'd like to acknowledge my colleagues who supported us during the investigation, especially Professor Dohaga, and also from Myanmar side, Professor Sandy, Dr. Tuntun, and Dr. Kwan, and my former PhD student who now works in Kisojiman Consultant in Singapore. She is originally from Myanmar. In fact, she was the person who helped a lot in the logistics and initial coordination with our counterpart during our investigation. Of course, I must mention that Japanese Geotechnical Society financially supported our investigation. I'd like to thank especially Professor Uzoka and Professor Nukunuki, who was the Secretary General at that time, also Professor Tobita, who was the head of our disaster management committee of Japanese Geotechnical Society. And also Myanmar Geotechnical Society, the President Dr. Han, and Federation of Myanmar Engineering Society, Mr. Tin, and also Dr. Fyo, and Mr. Kubota, who is the Secretary General for this special investigation team. And with that, I'd like to thank you very much. And if you have any questions, anytime tomorrow during the banquet dinner, you can ask me. Okay? Thank you very much.
Thank you. Thank you, Professor Hazarika. With that, all of the technical sessions for today is over. Tomorrow we have 5 invited lectures, 1 special invited lecture, 1 special keynote, as well as 3 keynote lectures in store for us. And today we have a cultural program which will be held from 7 to 8 p.m. in the same hall. Invite all the delegates to be part of the cultural program. Thank you.
Photo picture.